Today, in this class, let us study about comparison of fractions. Let us study how to compare the fractions. Let us study about equivalent fractions. Okay, comparison of fractions having same denominators. If the fractions have the same denominators, how to compare it? How to decide which is greater and which is smaller? Look at the shaded parts of the following figures. Here there are 7 equal parts in each of the figures. So, in the first figure, only one part is shaded. In the second figure, only 3 parts are shaded. Are the shaded parts of each figure are of equal size? Definitely yes. Here 1 by 7 is smaller than 3 by 7. Symbolically, we write 1 by 7 is lesser than 3 by 7. Observe the denominator 7 is the same in the both fractions. Numerator 1 is smaller than numerator 3. Okay? See, in the example 2, you can see there are 8 equal parts in the two figures. There are two figures. In the both of the figures, there are 8 equal parts. In the 8 equal parts, in the first figure, 5, 5 parts are shaded. In the second figure, 3 parts are shaded. So that's why we write 5 by 8 and 3 by 8. Here 5 by 8 is greater than 3 by 8. Denominator 8 is same. Numerator 5 is greater than numerator 3. Symbolically we write 5 by 8 is greater than 3 by 8. From this what we can understand? From this what we can understand? From these examples we conclude that if fractions have the same denominator, then smaller the numerator, smaller is the value of the fractional number. Greater the numerator, greater is the value of the fractional number. So if the denominators are same, suppose 5 by 8 and 3 by 8, if the denominators are same, then if the we can decide which number is greater and which number is lesser by seeing the numerator. If denominators let us think the denominators are same, then if the numerator is greater, then the fraction is greater. If the numerator is lesser, the fraction is lesser. Only if the denominators are same. Okay. So comparison of the fractions having same numerators. Let us have the fractions which have the same numerators but different denominators. Look at the shaded parts of the following figures. There are 5 equal parts in the first figure, and in the second figure there are 8 equal parts. In the first figure 3 equal parts are shaded, in the second figure 3 equal parts are shaded. But here which is greater? Is 3 by 5 greater or 3 by 8 greater? Here uh, uh, the shaded parts are 3 itself, and the numerators are same. The numerators are same, that is 3 and 3, but the denominators are different. In the first figure the denominator is 5, and second figure, in the second fraction, the denominator is 8. So which is greater? Then which is greater? We when the numerators are same and denominators are different, then the bigger fraction is the fraction which has less amount of denominator. If the denominator is less, then the fraction is big. If the denominator is big, and if the denominator is big, then fraction is small. Again I will say, the denominator is small, the fraction is big. If the denominator is big, the fraction is small. Example 2. Which shaded part is greater? Here there are 6 equal parts. In that, 2 parts are shaded. In the second figure, there are 4 equal parts. Again the 2 parts are shaded. The first figure can be written as 2 by 6 and the second figure can be written as 2 by 4. But here the numerators are same but the denominators are different. So the denominator is 6 in the first fraction and the denominator is 4 in the second fraction. In both of these cases, the numerators are same. We observe that fraction having the less denominator is greater. That is, the 4 is lesser than 6. Then the 2 by 4 is greater than 2 by 6. If the fraction has the lesser denominator, then the fraction is bigger. If the fraction has the bigger denominator, the fraction is smaller. We can conclude that if the fractions have the same numerator, then the greater the denominator, smaller the value of the fractional number. Smaller the denominator, greater the value of the fractional number. Okay. Here you can see 4 by 13 is lesser than 4 by 9. How? Because 4 is the common numerator, but 13 is the denominator in the first fraction and 9 is the denominator in the second fraction. So 13 is greater than 9. So 4 by 13 is become the smaller fraction. The 4 by 13 will become the smaller fraction and 4 by 9 will become the bigger fraction. Now we have one of the problems. We have some of the problems having the same numerator and some of the problem having the different same denominator. And let us decide which is the bigger fraction and which is the smaller fraction. Among 3 by 5 is greater than 3 by 7. 9 by 11 is greater than 9 by 15. 4 by 5 is greater than 4 by 7. 7 by 12 is greater than 5 by 12. 6 by 17 is greater than 3 by 17. 11 by 19 is greater than 5 by 19. 12 by 15 is greater than 12 by 21. 11 by 15 is greater than 11 by 17. 6 by 11 is greater than 6 by 15. 14 by 23 is greater than 5 by 23. 17 by 20 is greater than 12 by 20. 11 by 15 is greater than 8 by 15. So now let us understand what is equivalent fractions. Look at these. What is equivalent fractions? So look at these cakes. We have 2 equal parts and one is shaded, that is 1 by 2. Now in the second cake we have 4 equal parts and 2 parts are shaded, that is 2 by 4. And in the third cake we have 8 equal parts and 4 equal parts are shaded, that is 4 by 8. Therefore the shaded part of the figures are equal in size. We notice that in each case half of the figure is shaded. 1 by 2 is equal to 2 by 4 is equal to 4 by 8. So 1 is half of 2 and 2 is half of 4 and 4 is half of 8. Therefore, however you take, the value of all these fractions are half itself, that is 1 by 2. That's why these fractions are called equivalent fractions. What are equivalent fractions? Fractions which indicate the same value are said to be equivalent fractions. Om Shri Sai Ram. Thank you.